This is an overview of benefits and technology of Turbase, a platform for private and sovereign data and collaborative applications. Turbase presents a unique combination of benefits coming from its distributed data architecture. Designed for multi-party data sharing and real-time updates, it enables users to seamlessly blend third-party real-time data with their own. As a result, users gain actionable insights and the most accurate, up-to-date information from all available sources. In Turbase, most data processing occurs on end-user devices, which reduces the demand on server resources. When devices make data changes, they synchronize with servers for archival purposes, but share data directly with other devices. This significantly reduces network load on the server infrastructure. Efficient data lookup is achieved through a logical tree topology. This topology provides a single logical root, allowing full control over any data shared outside of the principal area of concern. Direct data sharing clearly identifies both the data owner and the authorized recipients. The platform gives users full control over who accesses their information. Additionally, users can obfuscate their ad profiles by allowing advertising networks to view only aggregated statistical ranges. These ranges are accessed via a shared server that cannot see individual user data. The platform is designed to support anonymous participation while offering options for semi-anonymous or personal registration. The platform enables collaborative processing by multiple applications across end user devices, facilitating the creation of highly specialized, interoperable applications. This opens development to independent software developers focusing on their specific areas of expertise. While read access to data is open, write modifications are strictly routed to the authoritative application. Local apps can aggregate device data to present cross-source insights. To prevent data leakage, all applications are open sourced and undergo rigorous security reviews, including data flow tracing. Turbase strikes a balance between data privacy and public security. Initial connections between users must go through the server branch system. However, data exchange is direct between end user devices. Because all users are registered at their local branch, other users in the community have assurance that they're dealing with locals or know the region of the user they're dealing with. Turbase has a logical tree server architecture with smart leaf nodes. At its foundation, the system geographically organizes users and controls external access while allowing tree indices to be traversed directly on user devices. The system utilizes local branches to connect end user devices either locally through the branch network or, if authorized, across international borders. Once a secure connection is established, data is exchanged directly between the devices. All user driven data processing occurs entirely on end user devices or leaf nodes. This includes data index traversal, as well as reading and modification of the underlying data. A logical tree topology is necessary to facilitate community localization and index data for distributed searches, ensuring both localization and topical visibility. The sovereign tree's physical structure can leverage modern cloud architectures while permitting the physical separation of private branches. A user's device or leaf is always assigned to its logical branch, revealing only the regional location while permitting anonymous or semi-verified registration. Initial leaf connections are established through sovereign trees, providing clear visibility into connection history. Once connected, data is exchanged directly between the leaves. All user requests are processed exclusively through their assigned local branch. User nodes only connect to their specific branch, and branches only accept connections from assigned local nodes. All regional user data resides on that branch's local infrastructure, ensuring strict compliance with local laws. To enable wide area analytics and disaster recovery, relevant data is replicated to parent branches as needed. Requests for local data are served directly by the respective locality's logical branch, without accessing parent branches. This applies to both the sovereign tree and any logical third-party typical trees that partition data by subject. Data is indexed locally using leaf-readable files. Conversely, leaf-readable metadata indexes are generated and served from parent branches and the trunk, alongside the indexes and data of other branches. Local branches only process requests for local data. Parent branches and the trunk remain hidden within the system, accessible only through their child branches. Independent sovereign trunks interconnect to enable international cross-trunk communication. Turbase collects ad revenue from advertising platforms for placing advertisements within applications running on end user leaves. Alternatively, users can opt out of advertisements entirely by paying a direct subscription fee to the platform. If a user chooses not to share their anonymized advertisement targeting ranges, the platform will only display advertisements targeted to the user's region or parent regions. Both advertising and subscription revenues are shared among hardware providers, application developers, and, in the case of advertisements, the end users. Revenue share with users can be used to cover costs for data storage and for in app purchases. Turbase features a localized, multi tiered, and highly redundant architecture. The edge branch nodes directly serving users process only local requests. This localized isolation mitigates distributed denial of service attacks and ensures administrative data localization. The same framework applies to third party topical trees. Broader information requests are routed up the tree hierarchy. A logical branch provides direct access to its leaves, allowing for IP range checks and additional verification of traveling members. All local public data is stored in a branch specific relational database, enabling analytical processing of that location's data. Private data is encrypted on end users' leaves using their passwords or biometrics and stored on the local branch. At login, a leaf authenticates the user on their local branch to verify their membership, regardless of whether the registration is anonymous, semi verified, or private. Leafs transmit records of repository changes to the branch they are registered on. For private or private group repositories, these change records are encrypted on the end user leaf. Once a connection is securely established through the branch system, leaves exchange data directly with one another. During direct data exchange, they only send synchronization notifications and change records to the branch for archival. Any personal, family, community, or commercial branch that needs public data access must register at its local public branch. Third-party branch users are authenticated by first being routed through a public branch to verify their residence and identifier. Local public branches enforce public data security by validating the Leaf's platform code during authentication and may restrict data processing to a pre-approved list of applications. By default, users are registered anonymously via an end user leaf node physically located in the branch area. For higher trust requirements, users may register semi-anonymously. A random group gathers at a registration point at a set time. Once the locality's user threshold is met, participants provide their IDs to prevent duplicate registrations. They then draw a number from a pre-allocated pool of registration tokens. This guarantees that a registered user holds a token for a specific group without revealing exactly which token is theirs. Users may also register openly by name. During their initial login, Users create a password and can optionally register biometric data. Turbase data is stored as change records, which are sent to branches for archival and retrieval. Data is aggregated and processed on end user leaves. Public data is stored in relational databases on the user's branches. Private data is encrypted and decrypted on the end user leaves. All third-party branches requesting access to public data must be registered at their local branch. All access to public data is verified by redirect to the public branch at the time of user login. Users only register at the branch in which they reside. A leaf is a framework that contains a physical relational database and acts as an execution environment for running applications locally. Within the leaf, applications are isolated from one another, the database, and the network via controlled communication channels, and they run securely in a virtual machine. Because they house both the local database and locally installed applications, leaves are fully capable of working offline. Application code cannot access the network or the leaf database directly. It must request network and database access from the leaf framework, adhering to strict access protocols. Applications may only interact with each other's application programming interfaces through the framework. While applications can process their own data, as well as data from other sources, an automated data analysis is performed during the application publishing process. This ensures that all data references remain within defined safety boundaries and cannot leak between users and groups. Applications store their data in relational database tables. Each application gets its own database schema to group its tables. An application's tables can reference tables in the schemas of other applications, building upon their data. Tables from one application can reference data in tables of other applications, allowing for data linking across the ecosystem. If permitted, applications can directly read data from other applications, creating data joins to access related information together. However, only the application that owns a table can write data to that table. Applications define database schemas to create data tables, though physically All data is housed in standard relational tables. Logically, data is organized into virtual databases or repositories. Any number of virtual repositories can reside within the tables of a given physical database. Repositories operate independently of specific applications and can span multiple tables across numerous applications. While an application usually controls its own write operations, other applications can also write data to the same repositories. However, the newly written data will be physically stored in the relational tables belonging to those other applications. Turbase data is always stored in virtual repositories. Physically, repositories reside in relational databases, with data being stored in tables. Applications interact exclusively with data in repositories. They can read data across any number of repositories, processing and aggregating it together. Additionally, applications can read data from tables defined by other applications and can call APIs of other applications to save data into their tables or to retrieve pre-processed data. At launch, Turbase will include a suite of built-in applications that deliver immediate value to users. Covering essential needs, these apps will share underlying database schemas and data APIs, creating a unified foundation for third-party developers. Because core data types are stored jointly, information doesn't need to be duplicated across apps or re-entered by users. The Turbase framework and application code will be open for inspection and verifiable by independent parties running audits on leaves. Maintaining openness in both the framework and application code will guarantee data security for all ecosystem participants. This open source approach will build and maintain trust in the platform and its applications. The platform's open source framework and application code will facilitate international adoption. Each participating country will separately control its own physical infrastructure of sovereign data trees and the data residing within them. Consequently, the logical tree trunks of these countries will be able to participate in the international exchange of authorized open data.